Hello everyone. Yeah, it's your friend DAPZY'S. I'm a data Walter Adetunji. Yeah, I remain your data analyst and scientist motivator. Motivating is the difference and with a sense of humor. Alright. Yeah, I will back again. Alright, on today's our data series content. Alright, and just as we started with the visualization of numerical variables, okay. And today we shall be looking at how to use scatter plot diagram, okay, to visualize numerical variables. Okay. Yeah, so I want to believe if you can remember what you've learned. All right. And so we're going to start straight away without wasting our time, without wasting much time. All right. Get onto your systems now. Open your spreadsheet, your Excel file. Okay. While I also share mine. And then we'll be looking at what we have for today. All right. So please just give me a thumbs up when you see my own Excel file. Okay. I'm going to be sharing mine. Um, by the way. Okay. Yeah, can you see my Excel sheet now? Okay, okay, I can see your hands. I can see your hands. All right, beautiful. All right, so we'll be looking at the example we have here. We are creating a scatter plot chart. Okay, and we have a student ID. We have student performance or the score in percentage. That's over 100. We have the number of times students were absent. Okay, so we're looking at out of 600 times. Okay, for the whole term or semester. Okay, the students should attend the school. So 600 times. So we can see here 216 for student one, the ideal one. This one was absent for 216 times 71. And we know that basically the number of times students uh, is present in school or absent in school, we also tell on their performance, right? Okay, on the academic performance. So imagine out of 600 times, my student should be in school, or number of times absent. Since now it's absent for maybe 216 times out of 600. So you know what that means. Okay. All right. But if the child is just absent for 71 times, okay, out of 600, then that means his score will better, will improve. Right. But imagine that the child is absent for 451 times, as in the case here, his score will surely be low. And so we can see the score here 46 over 100. All right. The one with 71 absent for 71 times at 80%. Okay, so because that actually looks um, real. So we're just going to look at how we can put this in form of scatter plot diagram. Okay, for our visualization as a data analyst and scientist. Okay, so we're looking at this class is a class of year 12 students. All right, so it's a secondary school, year 12 students, and basically, I would like to just quickly mention that scatter plot is used for displaying relationship between two variables, and that's two numerical variables. Alright, so we can say that same performance is in numerical variables, numbers, alright, from 30, 80, 40, 41, 84 down. And we can also see that number of times absent too is also in numerical form, okay? So it's the numbers. Numerical simply means numbers. So we have 216, we have 71, 250, and the likes, okay? Okay, so we'll be looking at comparing, we'll look at the relationship between student performance and number of times absent. Before I go into that, I would like to briefly explain when we talk about relationship, what does it mean in the world of data? Okay. Um, we have three types of relationship, or I can call them correlation. We have the positive relationship or positive correlation, and we have the negative correlation or negative relationship, and we have no correlation. That's when there's no relationship, right, between the two variables. When there's no relationship between two variables. Okay, all right. We'll be checking the relationship between these two um, columns. Okay, so student performance and number of times absent. So we'll be looking at this. So I would just like also, okay, so I'll click out here. All right, and remember I said scatter plot is used for displaying or showing relationship between two variables. Okay, between two variables. All right, so we'll be looking at these two variables here. So I'll just highlight it. Okay, and just click out. So let's come here. I like this and bring it straight down. Okay, to this point. So I stop here. Okay, and then let's come to insert. So we are inserting our chart. What chart are we inserting? You're correct. Scatter plot. So if you look at the scatter plot, that scattered this, all right. So it has dots that scattered, and you can see that once you over your mouse on this, it shows scatter plot. So I click here, and I just click on um, the first chart there, first image. Okay, so let's wait for it. Okay, and so yeah, and there we have it. Okay, there we have it. All right, so I'm just going to carry it up. Um, all right, so yeah, so I intentionally made this for this class. So let me just expand this, expand this. So if you look at this, the dots here represent the individual students. Okay, send ID 1, 2, 3 down to, you know, down to the number we have, number of students that we have. Okay, in the class, 106 students. Okay, so each of those circle, all right, denotes that, and so you can put your mouse there, and then it shows you. But if you look at the chart, we cannot see student performance on the y-axis, on the um, x-axis. Okay, so what we just do simply is we click on chart design. Okay, and then it comes down, and then we come to select data. Select data. All right, please, I want us to listen attentively. Okay, I'm going to take that again. I'm going to take that again. I'll cancel this now. All right. So um we'll click on, so I'm going to click outside. Let's click on the chart. Okay, so click on the chart, and then you click on chart design. All right, and come to select data. Now looking at select data, you see that we have 30, 80, 40. This 30, 80, 40, it's, yeah, 30, 80, 40. So this is student performance, and that's on the horizontal axis, meaning that by x-axis, the horizontal axis is our student performance or score, right? And our legend, which is the vertical axis, is our number of times absent. Do we get that? Do we get that? Okay. Just so don't forget, horizontal axis, our x-axis is our what? Student performance. So let's just click OK, and we'll come back again to chart design. I think I'd like to pin this or show ribbon. So come here, come to add chart element, then come to axis title, take it, and then we come to primary horizontal axis. So that comes out. Let's click here again. Let's click primary vertical axis. So we have the two displayed. So simple. So just click inside of the box. Okay. Inside of the box. Okay. And delete what you have there. So what do we have? Student performance. Don't forget. So student performance slash score. All right. So we're going to come here to the vertical side and also delete what we have here. Okay, so and then we just write what number of times absent, number of times absent. Okay, all right. Let's close this. We can choose to delete this and maybe name it, give it a name. Um, okay, we can just call it student performance performance sorry, visualization. Let's call it visuals. Okay, or charts. Yeah, let's call it charts. Okay, and so click outside. We're not formatting anything for now. Okay, now what I want to explain something here. You would see, remember I said earlier that we have the positive correlation, positive relationship, we have negative relationship, and we have no relationship. All right. Now I'm going to show us something. Now looking at this, we have so this student here, student ID, this student, okay, that's student ID 11. You can see there. For the student performance, all right, he had a score of 11%, all right, and had um, and number of times absent in school was what? 270, 270 times. So this was this 270 times a bit more, is much, and so because that it affected his score. Then look at that student. This one had 30%, and he also number of times absent from school was 216 times. Okay, let's come up here. This one had 8%. Number of times absent from school was 588 times. Wow, that was 600. So you can see no wonder he had this poor score. 8. Okay, let's take this student here, this standalone student. This one had 91%, and the number of times that he was absent was 470. So this is unusual. You see that this is unusual. I want you to note this. Unusual. Okay, another is standing alone. Because yeah, he was absent from school for 407 times, yet he still had 91%, 91 over 100. Amazing. So now, if you want to look at the relationship, so I click it and then let me click it again. So it's going to come open. All right. And so click on the thread line. Thread line. So a thread line appears. A thread line appears. Now it's stemming from left to right. Okay, so when you have the line come this way, all right, this is called a negative correlation. A what? A negative correlation. And I will explain. Meaning that for this person here who scored, he had let's just trace this down. So just imagine that between 0 to 20. So let's say he had 9%. 9%. All right. He had 9%. Why? Because I was absent from school for close to 600 times. That's at 599. All right. So you see it. There's a negative correlation, meaning that negative correlation means that the higher or the smaller a number, the higher the next number. All right. When you're showing your relationship. All right. So one must come down for one to go up. So if a student has a low score, meaning that he has a higher percentage of being absent from school. All right. If a child has a lower percentage of being absent from school, then he will have a higher score. So lower to higher, higher to lower. But if we have a positive relationship, as it's going high, the other one is going high. As it is increasing, the other one is increasing. For example, we want to have a positive relationship. We can compare quality of products to the price of the products. So the higher the quality, you know that if a product has a higher quality, so if we use the range of 1 to 10, all right, if the quality is 1, what will happen to the price? It will be smaller. But once the quality increases to 5, the price will also what increase. All right, because the quality has increased to 5, the price will increase maybe from 50 now to increase to 150. If the price increases to 10, what will happen again? The price, if the quality increases to 10, I mean, the price will increase also, right? So that's a positive correlation. And there's an increase in variable A, there's a corresponding increase in variable B. I don't know if you are getting that clear. That's a positive correlation. But for a negative correlation, when there's an increase in variable A, there will be a decrease in variable B. If there's a decrease in variable A, there will be an increase in variable B. And that's what we can see here. So in negative correlation, the line comes from left to right. While for a positive correlation, it comes from right to left. Whichever the way, whichever the case may be. Okay, I don't know if you're getting what I'm saying. So, but um, okay, for a negative correlation, it stems from, I will take it from below now. It stems from right to left. For a positive correlation, it stems from left to right. I think that's better now. So you understand that. For a negative correlation, I take it again, it stems from your right to the left. While for a positive correlation, it stems from your left to the right. So it increases this way. Why? Because there's an increase, corresponding increase on both axes. Why? For negative correlation, as one increases, the other decreases. Now you look at this, if you look at this is called the trend line, all right, showing this, and you will notice that there are categories, there are categories of data points here. This is one category, this is another category inside this line, inside this place. I see my cursor, and then we have another category here. Now we now have what we call outliers. Outliers simply means that when we have abnormalities in our data set, so I mean that this data set now, there's some abnormalities there. There are some abnormalities there, and I'll just show us that. So if you look at this chart, you see that we have some clusters here around here. All this belongs to one family. We have some clusters around here, and we have some others here. But look at this now, out, far away. So something must be wrong with that data point, and we'll see it now. See this one far away. Something must be unusual, must be wrong about it, and we'll see it. See this one here too. It's a bit far. Something must be wrong. This one too is a bit far. Something must be wrong. Okay? Something must be wrong. All right. So look at this one here too. Something must be wrong. Now who can tell me what is wrong here? All right? Abnormality. It is normal for us to say, as we said earlier, that once a child misses school, number of absent of his absenteeism, if it's very close to 600, all right, if it's 500, in fact, from 500 above, we should know that it will surely have a low score. That means he does not go to class. But look at this place now. This guy had 46%, and he was absent 599 times. Yes, he had 46%, close to average. So it's trying to tell you that this is unusual. Some would, that means he only came to school once, and he still passed, well, close to pass, like, close to pass. But let's look at something that will give us a good vivid explanation. Look at this now. This one has 65%. You are giving that 65 is a B. So you had the B. And he was absent from school for many times, 579 times. You can see it. 579 times. So close to 600 times, yet he had a B. So they will now have to look at, this from here now we can deduce something that this is not normal. Could it be that this child is so intelligent, is a genius, studying at home, or he, you know, took part in exam malpractice? So at this point, you can now pick this set of students, pick this one too that had 91%, and it's not, it was absent from school 470 times, absent in school 470 times. So, and they had 91%. So they can now pick these children. Let's test them again in privately. Let us see. Is it that they engage in exam malpractice? You will now check them. Look at this one here too. He had 11%, was absent in school 270 times. 270 times, and he had 11%. So looking at this, his score is very bad. Alright, it's very bad. Considering this number of times that I was absent from school, 270 times, and this is not up to 500 times, yet he had 11%, so there must be a problem. Alright, there must be a problem. So mean that this guy perhaps is not so good. Perhaps it was not alright, was emotionally abused or drained and could not perform well. Alright. So you see them, they are called outliers. Why? They are away from this line, from this line, from this other data point. They're away. I don't know if we're getting and you're understanding what we're doing. So that's fine. That's fine. That's fine. All right. Um, I would like to introduce to explain something. You must have heard of equation of a line. Y equals to ax plus b, right? y equals to ax plus b, where your y is your dependent variable. All right. In this case, your a is your slope, your x is your um, independent variable, your b is your intercept. All right. That's what we call the equation of the line. So when doing linear regression, many of you data scientists, you still meet linear regression, logistic regression. So let's look at this. So this is our line. As I said, this is what we call the equation of the line. And I'll just show you what that mathematics we learned back in secondary school, what it simply means. Very easy. It's not difficult. Let's right click on this trend line. So right click, format the trend line. So I click on format and then it brings this. Okay, so let's scroll down, display equation on chart. So let's look at the equation. It's gonna be displayed. Let's close it. Has it been displayed? Okay, this is it here. So I'll just move it up so we can see it, and um, let me try and enlarge it. Okay, so I'm just trying to just enlarge it so you can see it better. Okay, all this is not too big. Okay, let me try and reduce it a little bit. Let me try and reduce it a little bit. Okay. So I think it's okay like this. Now, as I said, this is our dependent variable y. That is y depends on all other variables here. It depends on x, it depends on the slope, it depends on the intercept. Okay. When our x is 0, okay, when our x is 0 and our x is the x-axis here, which is the student performance. So if we put it at 0 here, and we multiply 0 times 5 point minus 5.9, and that's 0 plus 629.72. That means our number of times students will be absent will be 629.27 if x is 0. And I think that makes sense, right? Because if a child has 0%, that means the child never attended school, never attended, all right, was absent all those 600 times, was absent. All right, but what I want to just quickly teach us now is I would like to go into predictive analytics. Predictive analytics, okay? Yeah, those who would like to go into data science, all right, this will be helpful for you, all right? This is predictive analytics. So, for example, for instance now, let's look at it. We have our student performance, right? So, students, let's just put student score, all right, and on this other side, we have number of times absent, right? Okay, so all right, number of times absent. So let's just form any score. Let's just form any student score. So let's now give our student score. Then we can now deduce the number of times that that student can be absent. All right, we can now deduce the number of times that student can be absent. So let's just put some scores like student score 60. Let's put 80. That's over 100. Let's put 98. Let's put 14. Let's put what again can we put? Let's put 77. All right. So I think we have three numbers. Now let's now predict now what a number of times that these students can be absent using this student score. Child that scored 60%. What how many times do you think this child will be absent? Child that scored 80%. You know. So um so just simply say equals to minus 5.9901 times, put it in bracket, x. Okay, so what's our x is this 60. Okay, so plus 629.27, and press your enter. So 269. So let's just bring this down. Okay, so we can round it off. Let's just take this to the nearest. Yeah, beautiful. Okay, so we can just see it here now that student score, student that had 60%. Okay, number of times I was absent was 270 times. Okay, and you can look at it that it actually makes sense because the child scored above average. So if it was an above 600, it's 300. All right. So based on our analysis, a child that scores 80%, yeah, it would the number of times absent will reduce, right? It's not be up to 600, so 150. Now this child scored 98%. Wow, very high. So he was absent for 42 times in school. But look at that that scored 14%. So this actually shows that he would surely be absent for like 545 times in school. So we're able to make that prediction. And the child that had 77%, what happened? It was absent for 168. So we're able to have a predictive model and analysis of our work. And okay, so I just want to add this our predicted values, okay, onto our chart. Okay, onto this chart. I want to add this predicted values onto the chart. So I'll just click on my chart and I'll come to chart design and I'll come to select data. Select data. So if you see that it has highlighted this, so I'll just click on add. Okay, I'll click on add. All right. So I'll leave my series name and I'll come to I'll click here series X values. My X values is what student score. Student score. So what do I do? I'll just pick all the student score. All right. And I would come here, delete this and leave the equal sign. Okay, leave the equal sign, and I'll come to number of times present and um take it down all the way, and I'll click on um okay. Okay. All right, and yes, and okay. Yeah, we can see it. We have all, so the yellow, can I say the yellow data points shows the predicted um values that we've just put in there, and this is the equation of the line using the formula y equals to um ax plus b. Okay, okay, and that what we have just done just now. All right, and just to show us how to use scatter plots, so in this class now I've been able to explain what outliers mean. They are abnormal variations in your data, abnormalities in your data. Okay, so I could see that here now that where a child is supposed to, a child who has missed class for 599 times, supposed to score a low mark, he had a very high mark. That's an abnormality. All right, and so this can actually inform decision making, all right, as a data analyst, and let you know, okay, can tell the school as a data analyst that these children that have these unusual marks, let them sit, take the test again or the exam again, and let's see. But all these ones that are within this line, the question of the line, they are good to go. Okay, so either they fail or they pass, they're okay. But the one that actually, passed when they didn't come to school at all or came to school for a few times, and the one that actually failed when they were present in school for a lot of time, they have to, so we take the exam. So I also want to believe that you understand all what we've done today. See you in our next class. From here now we'll be moving straight into um our tableau visualization. Yes, so I'll be teaching us how to use the business intelligence tools like Tableau, like Microsoft Power BI, all right, to create visualizations, okay, and create dashboards, interactive, attractive dashboards. All right, I still remain your data analyst and data scientist. Okay, that's what is my name. Adedapo Walter Adetunji. Cheers. See you next class, guys. Cheers.